Today's trig lesson involves revisiting some stuff you probably looked at in geometry. All right, does the Sohcahtoa look familiar? What does it stand for? Sine is opposite over hypotenuse. Good. Okay, let's fill those in. Sine is opposite over hypotenuse. Cosine you said was adjacent over hypotenuse. And tangent was opposite over adjacent. Did you learn the other three trig functions last year? Or did you just learn sine, cosine, tangent? Just those three? Okay. So when you see this, you know it means sine, right? Cosine, tangent. All right. The next one here, CSC, stands for cosecant. Cosecant. The cosecant is the reciprocal of sine. So we said sine was opposite over hypotenuse. Cosecant is going to be hypotenuse over opposite. Okay. SEC stands for secant. Secant is the reciprocal of cosine. So secant will be hypotenuse over adjacent. What do you think the last one is? Cotangent, yep. Cotangent is the reciprocal of tangent, so adjacent over opposite. Now, we're most familiar with sine, cosine, tangent. We use those a lot. But next year, when you are looking at your trig stuff, you will be working with all 6 of them. Okay, so it's good to have that basic information. When we talk about opposite and adjacent, we have to reference a specific angle. Okay, so in our picture here, we've got our right angle. This is labeled the side that's opposite angle A. So this would be talking about if I'm referencing angle A, side BC would be opposite angle A. Okay? Side AC would be adjacent to angle A. But if I shift and start talking about angle B, now this side is opposite B, and this side is adjacent to angle B. Okay? So you have to put it in the context of which angle you're working with. Okay? The one opposite the right angle is always going to be your hypotenuse. Okay? So, reciprocal functions. Sine went with which one? Cosecant. Cosine goes with secant. And the way I tell kids to remember that, you have 2 words that start with C and 2 words that start with S, right? They don't go together. So of your 3 main ones, sine, cosine, tangent, when you go to pair up the reciprocal one, you need the opposite letter. Okay? So sine goes with cosecant, cosine goes with secant. They only have 1 co-word in the pair. Does that make sense? All right. Tangent goes with cotangent. That's an easier one to remember. All right. So this is asking me to find the value of each of the 6 trig functions for angle theta. Okay? So using angle theta here, or angle A, we want to figure out which sides are opposite, adjacent, and hypotenuse. Which one would be opposite angle A? Side BC. And typically the side opposite angle A would be labeled side A. Remember that from geometry? Angles are capital letters, sides are lowercase letters. So side A here, this is opposite. This one where B is 12 would be adjacent to angle A. And then C is hypotenuse. How are we going to find C? Because if we're asked to find all 6 trig functions, we need all 3 sides. How can we find side C? Pythagorean theorem. Remember Pythagorean theorem? A squared plus b squared equals c squared. So we have a is 5, 5 squared plus b is 12, 12 squared equals c squared. 25 plus 144 is how much? 169 is c squared. When we square root that, we get 13. Would I worry about the negative option, negative 13? No, because we're talking about the length of a side. Okay, can't be negative. So now we have all of our sides. We know this is now 13. We can list all 6 trig functions. If we know our 3 main ones, to get the other 3 right, we just have to flip them. Reciprocals. All right, so let's start with sine. And I'm going to use the symbol theta because that's what they use to label my angle. Sine of theta. Sine, we said, was opposite over sine, opposite over hypotenuse. So opposite of theta would be 5, hypotenuse is 13. Okay? Cosine of theta. Which sides do we use for cosine? Adjacent and hypotenuse. So 12/13. And then tangent. Tangent is opposite over adjacent. So 5 over 12. Okay, so we've got our 3 main ones. Now we're going to do the reciprocal ones. Which one was the reciprocal to sine? Cosecant. Our abbreviation is CSC. Cosecant. If sine is 5/13, cosecant would be 13/5. All right, which one goes with cosine? Secant. SEC. Reciprocal would be 13 over 12. And the reciprocal of tangent is cotangent. COT would be 12 over 5. Questions on any of that? Okay. All right. We're going to skip our next one here. Just one quick question for you. Which side's missing on this one? Okay, so it's one of the legs, right? So when we do Pythagorean theorem, we're not finding C, now we're finding B. We okay with doing that? Okay. Let's move on. Yesterday we talked about 30, 60, 90 triangles and the ratio of their sides. When we introduced it earlier, we said our short side would be opposite the 30-degree angle, and we called that x, right? We said hypotenuse was 2x, and the long leg was x root 3. When we're looking at that, those are the biggest options, but they're all going to come down to the same ratio. Okay? So if we label the short side as 1, in relation to x being 1, our hypotenuse would be 2, and our long leg would be just 1 root 3. Does that make sense? So we're looking at just the most basic 30, 60, 90 triangle. Okay? All right, so if I want you to fill in this table, the first one here is asking for sine, cosine, and tangent of a 30-degree angle. Yesterday we talked about converting that to radians. Are we okay with thinking of 30 degrees as pi over 6? We've got 180 degrees on the top half of our circle, and we cut it into 6 chunks. Remember that? Okay. So 30 degrees or pi over 6 are equivalent. I want the sine of that. So I'm using my 30-degree angle as my reference angle here. Okay, and I want to refer to opposite and adjacent based on that. So what's the side that's opposite 30? The 1. And if we want sine, we need opposite over hypotenuse. So the sine of 30 is 1/2. Okay. Keeping with that same angle, what would the cosine be? Cosine? Adjacent over hypotenuse. So this time it would be √3/2. And tangent. Tangent's opposite over adjacent. So 1/√3. We typically don't leave them like that. We rationalize it and it would turn into what? √3/3. Yep. Okay. Let's go ahead and do the 60 column next because we're dealing with that same triangle. But now we're looking at this as our angle. Okay. So sine of 60, or pi/3 if we want radian measure, sine of 60 would be √3/2. Cosine of 60 would be 1/2. And how about tangent of 60? Tangent of 60. √3/1, which is just √3. All right. Compare the two columns that we've just done. We've got the sine of 30 being the same value as the cosine of 60. Yes? And the cosine of 30 is the same as the sine of 60. Okay? Tangents are reciprocals of each other. All right. Go ahead and look at the 45, 45, 90 triangle. In that one, the two legs, the shortest, most common side length would be a 1. And we said then the hypotenuse is that side length times √2. So we have a triangle with legs 1, 1, and a hypotenuse √2. What would the sine of 45 be? So opposite would be 1/√2. Rationalized, we would write that as √2/2. Yep. How about cosine of 45? It's going to be the same, right? Because opposite and adjacent are both 1s. All right, so 1/√2, again, rationalized would be √2/2. And the tangent is just 1. All right. Those are going to show up next year on your unit circle, and we'll use them a little bit when we look at some of our graphing of trig functions in a couple days. In the charts here, we have a couple trig identities. These are called fundamental identities. We've already talked a little bit about the reciprocal ones. We said sine is the reciprocal of cosecant. Okay? And cosecant then would be the reciprocal of sine. All right? So cosecant means we take the reciprocal of sine, 1/sine. Sine takes the reciprocal of cosecant. Okay? In our next column, we've got cosine and secant. You can see that reciprocal notation. And same with tangent and cotangent. The other one that's useful is our quotient identities. The first one says tangent is equivalent to sine divided by cosine. I want you to think about that for a minute. If we take sine divided by cosine, and we refer to sine as opposite over hypotenuse, okay? We said cosine was adjacent divided by hypotenuse. How do we divide fractions? A fraction divided by a fraction, we actually multiply by reciprocal. What happens if I take opposite over hypotenuse times the reciprocal of this, hypotenuse over adjacent. We end up with opposite over adjacent, which we said was tangent. Okay, so we've just proved that tangent is really sine divided by cosine. That's helpful because we may not know what the hypotenuse is. If we know a sine and cosine value, we can just divide them to get our tangent. Okay, and then cotangent, we said, was the reciprocal of that. All right, so our first example for those. It says find the value of each of the 4 remaining trig functions given that the sine is 2/5 and the cosine of theta is the square root of 21 over 5. So if we know those two, can we get their reciprocal ones right away? All right. So if the sine is 2/5, then cosecant would be 5 over 2. If the cosine is the square root of 21 over 5, then we know that secant is the reciprocal, 5 over root 21. Let's go ahead and rationalize that. Makes it messier looking, but we typically would rationalize our answers. 5 root 21 divided by 21. Okay. Now we can use our quotient identity that says tangent is sine divided by cosine. We said the sine was 2/5. We said the cosine was the square root of 21 over 5. What's going to drop out? The 5s. We're going to end up with 2 divided by square root of 21. And again, if we rationalize it, 2 root 21 over 21. What's the last trig function that we have to find? Cotangent. All right, cotangent is the reciprocal of tangent. You're better off going back to the unrationalized version and flipping it over. Because if we start with this, when we flip it over, now our square root piece is in the numerator, and there's nothing to rationalize. Okay? If you have to flip over the one we rationalized, you're going to create a square root in the denominator, which means you're going to have to rationalize it again. Okay? So 2 divided by the square root of 21, we're going to flip that. We'd have the square root of 21 divided by 2. Questions on using that quotient identity to figure out a trig function? All right. We're going to go ahead and skip that one. One of the other identities that's very important and often shows up on those ACT tests is what we call the Pythagorean Identities. Kind of is like a squared plus b squared equals c squared. It's kind of going to fit that Pythagorean theorem idea. All right. We have our main one says sine squared plus cosine squared is 1. Okay. Sine squared of theta plus cosine squared of theta gives us a 1. I did put a little note on the side here. The notation, when we write sine squared of theta, we're really saying find the sine of theta and then square that answer. But we put the square in front of the theta symbol because if students aren't careful with their parentheses and they write it like that, then you're just squaring the angle, not the sine of the angle. Does that make sense? So we typically move that square symbol ahead of the theta so we don't have to deal with the parentheses. Okay? So sine squared plus cosine squared equals 1. If you can memorize that one, you actually can create the other two. All right, I'm going to show you how. If we start out, sine squared of theta plus cosine squared of theta gives us a 1. I want you to divide everything by sine squared. Okay? Now, what does that give us? What's sine squared divided by sine squared? 1. Cosine divided by sine is which trig function? Cosine divided by sine. It's cotangent. So cosine squared divided by sine squared would be cotangent squared. Okay? And 1 divided by sine squared, think of its reciprocal. 1 over sine is the same as cosecant. So 1 over sine squared would be cosecant squared. All right, we just found that one. We took our main one, we divided everything by sine squared, and it turned into this. If we did the same thing and divided everything by cosine squared, we'd get this one. Okay? So rather than having to memorize all 3, if you can memorize 1 and just know how the other 2 are created. This is the one that is used the most. Again, that does often show up as a question on the ACT test, somehow using that theorem, or that identity. All right, so our example says find the value of cosine theta using a trig identity given that theta is an acute angle. What would it mean to say theta is an acute angle? It has to be less than 90, okay? So we're talking about angles between 0 and 90 degrees, which means quadrant 1. And in quadrant 1, all our coordinates are positive, okay? We'll look at that a little more in the next couple of days with the unit circle. But what this is basically telling me is that all trig values are positive. All right, we're going to start with our Pythagorean identity that says sine squared plus cosine squared equals 1. We know that the sine of theta is 3/5. And if I want to square theta, or sine theta, I just have to square 3/5. Okay, that would be sine squared. So 3/5 squared plus cosine squared should get us 1. What is 3/5 if we square it? Keep it in a fraction form. 9 over 25, 9/25. So we've got 9/25 plus cosine squared of theta equals 1. Can we subtract the 9/25 to the other side? What do we get if we take 1 minus 9/25? (16/25). So now we've got cosine squared equals 16/25. So to get cosine, we're just going to square root that. So cosine theta, and here's why I said don't worry about the plus minus. Typically when we square root, we have to consider positive and negative values, right? But we are in quadrant 1, all of our angles are acute, so the cosine would be 4/5. All right, I'm going to pause the recording. I want you guys to do the next one. All right, checking our last answer here. We know sine squared plus cosine squared equals 1. We said sine was a half, so we have to square that. What's 1/2 squared? 1/4. So we're going to have cosine squared being 1 minus 1/4. All right. If cosine squared is 3/4, what do we get for cosine? Agree? Square root of 3 over 2? Okay. All right, we are going to check some things on our calculator. We do a lot of work with 30, 60s, and 45-degree angles. Lots of work with that in trig. But there are other angles out there, and you aren't going to know, for example, what is the sine of 23 degrees. Okay, so we would use a calculator to help us find that. If it is a 30, 60, or 45-degree one, we'd want those exact values from that table we filled in. Okay. We need to make sure we know what mode our calculator is in. So hit your mode key. And if you scroll down a couple lines here, do you see where it says radian and degree? By default, your calculator goes to radian measure. So if you ever reset it, it's going to reset it back into that radian measure. So anytime you are using your sine, cosine, tangent keys, make sure you check what mode you're in first. It's very common for students to calculate the sine of an angle in the wrong mode. And if it's a multiple choice test, they're going to put that wrong answer on there, right? They're going to see if you know to pay attention to whether it's in degrees or radians. Okay, so watch out for that. Let's go ahead and change it to degrees. That's the one we're going to do first. All right, so highlight degrees, and then we can quit out of that. All right. So using a calculator, we can find the sine of whatever angle we have, whether it's in degrees or radians, just making sure we have the mode set. If we want to use something other than sine, cosine, and tangent, if we want to use those other three trig functions, keep in mind that they're just reciprocals of the other three. So if I want to do cosecant, I'm really going to do 1 divided by sine. If I need secant, I'm going to do 1 divided by cosine. And cotangent would be 1 divided by tangent of that angle. Okay, so your calculator only has sine, cosine, tangent, but you can flip them over to get the reciprocals.
So is the reciprocals what the sine of the negative one thing is?
Good question. We're going to come back to that. Right above your sine, cosine, and tangent keys, you see the word with the little negative symbol? That is inverse sine, inverse cosine, inverse tangent. That is not the same as secant, cosecant, and cotangent. Okay? All right. It says use a calculator to find the value to 4 decimal places. So we want the cosine of 48.2 degrees. That means we need it in degree mode, right? So in degree mode, we're going to type the cosine key, and then we're going to put in our 48.2 and hit enter. So what would our answer be to 4 decimals? 0.6665. Okay. Our next one, we want to do the sine of 72.8. Sine of 72.8 degrees. We get an answer of point what? 9553, rounding it to 3 decimals. How would we do cotangent? All right, so we're going to type in 1 divided by the tangent of 56.3 degrees. All right, and we should be getting 0.66, I lost it, 0.6669. Okay. Looking at the next 3, what do you notice? They're not in degrees, right? There's no little degree symbol. So go back to your mode and change it to radians. All right. We've got radian mode. All right, go ahead. I'm going to pause the recording. You guys go ahead and fill out those 3. You do have a pi key on your calculator. All right, so tangent of 1.2 radians should be 2.5722. We okay with that? Secant of pi divided by 12, and you use the pi key. All right, you should have 1 divided by cosine of that is 1.0353. And 1 divided by the sine of pi divided by 5 is 1.7013. We okay with doing that calculation? All right, so again, just make sure you pay attention to what mode your calculator is in. The last little bit that we're going to talk about deals with some word problems using trig. First hint I would give to you is to draw a picture if you aren't given one. Okay? Label any angles or sides that we know. Determine which trig function would be helpful based on the given information. Are you dealing with opposite and adjacent? If so, use a tangent. Okay? If you are finding a side, you will be using your sine, cosine, and tangent keys. If you are trying to find an angle, you will be using those inverse sine, cosine, and tangent keys. The ones right above, all right, that Zach mentioned earlier. Okay? All right, so first one. Whoops, forgot one other thing. Do you guys remember from geometry the terms angle of elevation and angle of depression? Okay, elevation is from horizontal looking up. Depression is from horizontal looking down. Yes? In this picture, notice angle of elevation and angle of depression are the same because your horizontal lines are parallel, right? And it's a transversal. Talked about that the other day. Okay. Sighting the top of a building, a surveyor measured the angle of elevation to be 22 degrees. Where would I put that in my picture? Where would I put that 22 degrees? All right. Far right angle here. Okay, angle of elevation from horizontal looking up. It says the transit used to measure the angle was 5 feet above the ground. So this distance right here, that little space at the bottom there, is 5 feet. Okay. The transit was also 300 feet from the building. So the transit's over here, right? We're measuring that angle of elevation to be 22 degrees, and we are told that we are 300 feet from the building. We want to find the building's height. So using our triangle, the building's height is all of this, correct? We're going to take off the little 5 feet at the bottom. We'll put that back on later. So we can use our triangle. We'll find x here, which again only goes to the end of that triangle. Okay? And then we'll add in the 5 later. Which trig function, if we're using angle 22, which sides are we given? And which trig function makes sense? We have an opposite side that we've labeled x, and we have an adjacent. Opposite and adjacent uses tangent. All right, so we're going to set it up with a tangent. The tangent of our 22-degree angle is what ratio? X divided by 300. So to find x, we just have to multiply 300 over there. So 300 times the tangent of 22 degrees. Make sure you go back and put your mode in degree mode. And then do 300 times tangent of 22. What are we getting? 121.2? Now, remember that's the x part. We have to add to it what? The extra 5. So the building's height We have to add 5 to that. We're going to get 126.2 feet. All right. Question 9. The irregular blue shape represents a lake. The distance across the lake A is unknown. To find the distance, a surveyor took the measurements shown in the figure. What is the distance across the lake? So we know we have a side here that's 750. We know we have an angle that's 24, and we're trying to find this angle over here, or that side over there. Which trig function should we use? Sine, because this would be opposite, and this would be hypotenuse. Okay, so set it up. The sine of 24 degrees equals opposite over hypotenuse. So again, we just have to multiply the 750 over to the other side. What do we end up with? 305.1, and that was in yards. All right, our last one. It says a building that is 21 meters tall casts a shadow that's 25 meters long. Find the angle of elevation to the sun to the nearest degree. All right, so how are we going to label our sides in here? The height of the building is 21. So I'll put a 21 there. And where do we put the 25? At the bottom, right? Along where the shadow would be? Okay, and what angle are we trying to find? This one over here, yes? Which trig function is being used? Okay, so the trig function would be tangent, yes? The difference with this one is we don't know the angle, right? We're taking the tangent of some angle, and we are supposed to get 21 over 25. Now, here's where we're going to use that inverse feature. So x is going to be the inverse tangent of 21/25. And if our calculator is in degree mode, it's going to give me the angle in degrees, okay, which is what they asked us to do. So you have to do second tangent, put in your 21/25. And it did say to round the answer to the nearest degree.
40.
So we should be getting an angle of 40 degrees. We okay with that? All right. So homework tonight, you have a white worksheet. Again, you are doing the circled questions on the white sheet.